Alright, today we are going to be discussing balancing of redox reaction. If you look at our previous class, we discussed how to identify oxidation number of elements in a compound, rules that guide us in identifying the oxidation number, as well as how to also identify oxidants and reductants in a chemical reaction. And if you've not forgotten, I say that anytime there's an increase in oxidation number, that particular element is undergoing oxidation and itself is a reducing agent. And when it's a decrease in oxidation number, that element is undergoing reduction and that element itself is an oxidizing agent, which means oxidation and reduction reaction involves a gain and loss of electrons. So today we are going to be balancing redox reaction. Now, before I start, I want to recall your attention to the rules that we use when assigning oxidation number to a particular element, because such is also applied in balancing redox reaction. For example, for an element in an uncombined state or an element that whose atom combine with themselves to form a molecule, the oxidation number of such element or molecule is equal to 0. Number 2, for an ion in this single state or a radical, the oxidation number is equal to the charge that the ion has. All group 1 element has a combining power, or should I say an oxidation number of +1. All group 2 has +2, group 3 is +3, although it might change for the latter. And the halogens are always -1, although sometimes we might have a variable oxidation number for chlorine, fluorine, and iodine in interhalogen compounds. And also, oxygen always have the oxidation number of -2, although in hydrogen peroxide it is -1, and in superoxide it is -half. And hydrogen always have the oxidation number of +1, although in hydrogen halide it changes to -1. Now let us see how we can balance this redox reaction. I will guide you on how to balance this particular example that I have on the board. For those of you writing in JAMB and WAEC, this should be a guide for you in balancing whatever problem they gave you in your examination to solve. Now let us see. Now we are asked to balance this reaction in an acidic medium. In an acidic medium, I'm going to teach you how to balance an acidic medium. Then in our next video, I'll also teach you, or maybe now, how to balance a basic medium. Now, first of all, you have to look at it and identify which is undergoing oxidation and which is undergoing reduction. That is the first you have to do. And just like we said, increase in oxidation number means oxidation, decrease in oxidation number means reduction. Now, ion is moving from +2 oxidation number to +3. Definitely, this is an increase in oxidation number. We call this oxidation. Whereas, if you look at this, we are having manganese here, which is reacting with this oxide, and we have manganese ion here. Definitely, we have to confirm the manganese to know the oxidation number. And definitely, if you look this here, this is oxygen, and it is tetratomic here, and oxygen is always -2 in compounds like this. So 4 - 2 is -8. So which will I add to -8 to make the oxidation number of this compound to be equal to -1? Because if you remember, I said that the oxidation number of a radical is equal to the charge that is found in that particular radical. So in this case, if this is -8, definitely the oxidation number of manganese is 7, because 7 - 8 will give you -1. So if the oxidation number here is 7, the oxidation number here is +2. So this is a decrease in oxidation number, which we call reduction. So now if you look at this now, you now, step number 2, you write the half equation of the reaction, which is the half equation. We have oxidation, which is for the oxidation, we have F, that's ion 2, to give us ion 3. And for the reduction, we have manganese, that's the also manganese 7, to give us manganese ion. Now in this case, you have to check the equation to make sure that what is on this side is equal to what is on this side. Now before I continue, let me remind you, remember I told you that any particular element or ion that is undergoing oxidation, it is itself a reducing agent. It simply means that this ion here is a reducing agent, and reducing agent has the ability to what? Donate electron. Why? Any element that is undergoing reduction, it is an oxidizing agent, and oxidizing agent has the ability to accept electron. So let's continue. Now, if you look at this now, let us start by balancing the ion. Yeah. In this state, we have one ion here, one ion here. So let me put it this way. This is equal to, if I have 1 mole of iron, or should I say ion, to give me ion 3 plus. That is from ferrous to ferric. Now in this 2 is in this state. If you look at this, the atoms of the ion is the same, but the charges are not the same, because here you have 2 positive charge, you have 3 positive charge. So you have to make sure that the charge here is equal to the charge. So definitely you just have to add an electron here to balance the charge, meaning that 3 minus 1 electron is equal to 2. In this case, this is balanced. So you continue by balancing the reduction part of the equation. Now to balance this, you have to be very careful, because in the third rule in balancing redox reaction, we are told that whenever there is an oxygen, you balance the oxygen by adding equal atoms of water or equal mole of water. If there is 1 mole of oxygen, you balance by adding 1 mole of water. If there is 2 moles of oxygen, you balance by adding 2 moles of water. So in this case, if you want to balance this now, you start by saying, okay, I think I can do it down here. Let's use this MnO4 minus to give space, so you can add Mn2 plus. So if there's a 4 atoms of oxygen, I'm going to add 4 moles of water here to balance it, because if you notice, you have 1 manganese, you have 4 atoms of oxygen, no oxygen here, so you add water to balance oxygen. Now I've introduced 4 moles of water, meaning that now I have 4 mole of oxygen, and now I have 8 atoms of hydrogen. Now in this case, I have to balance the hydrogen atom by adding an hydrogen ion at this side, what we call the reactant state, part of the equation of the reaction, which is plus 8H plus. Now I'm having 1 manganese, 4 oxygen, because this 4 is affecting everybody here. Then I have 8 hydrogen, Now what about the charge? Now in the charge, if you notice here, you have 8 atoms of hydrogen, which is 8 positive charge, and here you have 1 negative charge looking at 2 here. So when you look at this now, 8 minus 1 is 7 positive charge here. You have 7 positive charge here. Here you have 2 positive charge here. So what will you do to make this charge to equal to this charge? You add an electron. That means you substitute by adding an electron. That means substituting the charge, like plus 5E minus. Now, what if an answer is 7 minus this 5 is equal to 2 positive charge, is left 2 positive charge, that means it's balanced. It is not balanced. Now, this is what you have to know, because in your job examination, you are not going to be asked to balance this way. It is only why they might ask you to balance this. It might just be stage. For example, now this stage, you say, what is Y? They just put Y here. See, what is Y? You know, the symbol Y is what? They give you A, 2, B, 3, C, 4, D, 5. You just have to balance it, the chart, then you know that actually it is 5. Now, having done this, now the next thing you have to do now is to make sure that the charge on the oxidizing part is equal to the charge on the reducing part. So now, if I have, I mean the electron here must be equal to the electron here, so that you have to make the electron equal to cancel out or eliminate the electron out. So that's kind of elimination method. So in this case, if I have 5 electrons, I have to be multiplying this part of the reaction, that is auxiliary part of the reaction, by 5. I have to multiply by 5. So if you multiply by 5, you know, you're going to have 5 times Fe, that is 5 Fe2 plus, okay, to give us, because it's the reactant part of the reaction, to give us 5 times this, 5 Fe2 plus 5E minus. Now you can substitute the, you can eliminate the electron out, because it's occurring, is now out. Then you add both of the reaction together to get your final answer, which is the reactants to the reactants, the product to the product. So you start by this. You can start anywhere. Since it started from iron, let's start from iron. Let's say 5 Fe 2 plus MnO4, which is called tetraoxomanganate. If you look at the oxidation number 7, so this tetraoxomanganate 7 ion, and plus 8 hydrogen atom. Then you don't need to add this, you've already eliminated it. So if you go to the product side, to give you have F, now in this case 5Fe, because you are adding this to this to this, 5Fe, 5 moles of iron atom plus manganese plus 4 moles of water. So let us check if this is balanced. Let us check, because what is here must be equal to what is on this side. So let us check. We have 5 mole of iron, balance. Iron, 5, iron, 5. What about manganese? Manganese, 1, manganese, 1. What about water? Okay, let's see hydrogen. Hydrogen, H, we say 8. Hydrogen here, we say 8. Hydrogen 8. That's 8. Then what about oxygen? Oxygen here we have 4. Oxygen here we have also 4. Then what about the charge? Charge, like I said, now you have to be very careful now. Watch, this is 2. Now this 5 is affecting this charge here. So this 5 times 2, 10. Plus 8, that is 18. 18 minus 1, 17. Positive charge. Positive charge. Then what about here? Let's see. 5 times 2 is 10. 10 plus 2 is 17. Positive charge. So what is here is equal to what is side. So in this case, we have balanced this equation in the acidic medium. So let us keep it at this. In our next class, or in the next, if you go to my video, you will see where I'm going to be solving, and I'll use another example to solve balanced redox reaction in a basic medium, so that when you see it in examination, it will be very easy. So please, I beg you to subscribe to my channel and keep on watching the videos, and like and comment whenever you have any question you want to ask. Comment on the video, and like I said, I'm going to be making series of videos in mathematics, physics, chemistry, and biology. So thank you for trusting on this channel. God bless you.